Excellent. Thank you very much. So, as was mentioned, my name is Joe Disher, and I'm a senior product marketing manager here at Amazon Web Services. And with me today, I also have Daryl Osborne. He's a storage specialist and a solutions architect. Today, we're going to talk about how to build out a cloud scale website powered by Amazon EFS. We're going to go through the 4 phases that it takes to build out that platform. First, we're going to discuss how to choose your storage platform, digging a little bit deeper on the different options you have available to you. Second, we're going to talk about how to choose your website platform. And then finally, I'm going to hand it over to Daryl, and he's going to go through how to build, deploy your options, and then talking about some of the best practices around performance and running and monitoring your system with Amazon EFS. So let's talk about choosing your storage platform first. So first off, there's various storage types that I'm going to go through and talk about so you can understand at a very high level at least what you need to consider as you start considering the different storage options that you're going to use. Then I'll go through, and when you go through this on your own, you'll have to take those different storage options, consider them relative to the features and performance that are available with the different constructs. And then obviously, once you deploy and roll out within your particular application workflow, you need to consider the economics and the costs. At the highest level, the things that we think about when we're rolling out our new applications are the 3 fundamental storage types. And what I'll talk about today is file, block, and object. And we have offerings in each of those at AWS. And we'll dig a little bit deeper on EFS and file workloads in particular. But I'm going to talk a little bit about the different workloads first. First off with file, it's important to recognize why file services are still so important. Excuse me. Data stored on file storage is typically hierarchically ordered and provides you the means to share that data amongst groups, amongst applications, or for users of their home directories and things like that. Essentially, it's specifically built for low latency, consistent sharing of files. Next, I think everyone's familiar with block storage. It's essentially the foundation for most applications when you start off with just having a host connect up to a volume. Data is stored as blocks on regular disks, volumes, or multiple disks. And then it's typically locally attached. In the world of cloud storage, it's all virtualized, obviously, but from a host OS perspective, it's still quote unquote locally attached storage. And then there's object storage. Object storage is really identified across a flat space, and in the terms of S3, it's in buckets of storage so that you can maintain all of your objects, which by the way could be files, but all of your objects within that bucket of storage. It utilizes a simple API as opposed to a typical network access protocol for accessing files, but that API allows you to put and get your files within that flat space. So why is file storage so popular? Well, first off, it's been around for quite a long time, and as I've mentioned before, it's particularly handy when you're sharing access and you need to provide consistency that's guaranteed, and of course file locking functionality. It does work natively within an operating system, and that's important so that there's no special new code that needs to be written to access those files in that storage. And again, as I mentioned, it does provide you with a hierarchical namespace so that you can have folders and folders within folders and have them organized in a way that is logical for when you're accessing it. And it's especially handy if you have different users that are accessing the data so that they can see how to traverse through the hierarchical storage tree to find that data. So when you look at the performance paradigm for our storage elements, we tried to align it in a couple of different ways. So first off, if you look at throughput, and then secondly, as you look at latency, and which is better for your application is somewhat dependent on the throughput and latency requirements of your application. If you look at block storage, that's your lowest latency and storage protocol. It allows you to have very fast response times for any applications that require that super low latency. And it does have reasonable throughput, but it won't scale. It's really meant, block storage, as we talked about before, it's really meant for that locally attached single node or single host accessing it. File storage, on the other hand, does have much higher throughput and scales as your capacity grows in our case, and I'll talk about that later, but it does provide you with more throughput, and it has a little bit more latency. And when you go to object storage, although it's massively scalable and it does provide really good performance from a throughput standpoint, it has lower latency because remember, as I mentioned before, it's maintained across that flat space. So there's no hierarchical tree, there's no metadata, there's no way to easily access that without having to go get that data directly through API calls. And that adds a bit of latency into the process for accessing data. So before, we're going to talk about Amazon EFS, but before there was Amazon EFS, when you wanted to share files in the AWS way, folks would have to do a few things that were pretty typical for an on-premises deployment when creating something that's highly available. The first of which is to create a file server. And in some folks' worlds, that meant a network attached storage server, a NAS server that they would deploy. And if you wanted fault tolerance, you would have to create another node or another NAS head or another file server to do that. In the world of the cloud, you would do the same thing. And so you would create that file server, in our case using EC2, and you would attach some EBS storage volumes to it and perhaps even some redundancy in the storage volumes. And that would be okay. But it won't necessarily provide you with the redundancy that you require. Most applications need high availability and will not tolerate any downtime. And so you would have to create yet another file server and add more storage volumes. Both of those things have a few downsides. Number one, there's a little more cost involved because you have to pre-provision your storage capacity based on what you believe will grow. And you also need to essentially guess on how much compute throughput you need. And you have to monitor that and manage that over time. And essentially, all of the administration overhead that you had in the past with your on-prem solutions, especially if it was just a traditional file server, still exist. You have to manage and maintain it yourself and ensure that everything is up. And in particular, with solutions that require availability, you have to, when you're talking about availability, you have to make sure that you have all of your components and your networking set up to create that availability. So now let's dig a little bit deeper into Amazon EFS. So some of the key features with Amazon EFS are around the simplicity that exists with Amazon EFS. When we designed EFS, our first core tenet was simplicity. Since it's a fully managed service, there's no hardware, networking, or file layer to manage with a few clicks. You can create scalable file system in just seconds. There's also a simple pricing model, and I'll talk about that in just a few minutes. Next, it's elastic. Our second core tenet, of course, being elasticity. The file system will automatically grow and shrink as you add or remove files, and that's really important for cost. Again, I'll talk about that in a moment. But there's no need to pre-provision that storage capacity or even performance for that matter, and you only pay for the storage space that you use with no minimum fee. The third core tenet was scalability. EFS file systems can grow to petabytes of capacity and grow with throughput as well. And the file system drives scale automatically as the file system grows. So as you add more capacity and as more files are added, you automatically get more capacity. And of course, that all happens while providing consistent, low latencies, regardless of the file system size. And we also support, in this case, thousands of current connections. Again, another difference between, say, a block storage device and in a shared file paradigm. So important to remember, when you need to share files, thousands of connections at once, a file system like EFS is super handy to have around. And finally, it's across all of those tenants, we have high availability and durability. Let's see, get our slides moving here. Apologies, folks. So now we're going to talk a little bit about the security paradigm. So shifting gears just a little bit. EFS provides a variety of mechanisms to control access to your system resources. First, you can control network traffic using Amazon VPC security groups and network access control lists. Next, you can control file and directory access using POSIX permissions. Third, you can control administrative access using IAM action level and resource level policies. And finally, you can create a file system that you can enable encryption of data at rest as well as encryption of data in transit. We just announced that recently in April. So that the data in your file system can be completely secure as it goes across the wire and then, of course, when it lands on disk. Data encryption in transit utilizes transport layer security 1.2 to encrypt that data sent between your clients and EFS file systems. And this is configured per client that you have the file system mounted to. And speaking of EFS regions, you can use EFS in the following regions. We have Oregon, West in California, Virginia, Ohio, and just announced actually yesterday is, and it's up on the screen, is Asia Pacific Seoul. So it's important to know that we're going to continue to evolve and add more regions over time. EFS economics are simple as well. There are no minimum commitments or upfront fees. Since it's a fully managed service, there's no hardware to manage, so there's no need to provision storage. It automatically grows and shrinks as you add and remove files. There are no other fees, charges, or billing dimensions. There are no request charges. It's a simple pricing model, per gigabyte per month. And because our costs vary from region to region, so does the price. So as you start to roll out in different regions, just make sure you're aware of that. Remember the do-it-yourself setup that we talked about before? Well, keep in mind the various costs that existed. You had to consider EC2 and EBS and your connection links for replication and all those sorts of things. With EFS, that all goes away. So to keep that in mind. Oh, my build slide. Apologies, folks. All right. In this TCO example, we'll talk a little bit about how you can save money by going to a fully managed EFS solution as opposed to doing it yourself. In this example here, we're storing using 500 gigabytes of storage, and you can see that just doing the simple math at 30 cents per gig per month, that comes out to $150 per month. If you do it yourself, you have to consider over provisioning a little bit because you'll need some redundancies for RAID. So 600 gigabytes in this case with 85% utilization. Give yourself some buffer. The storage costs, compute costs, and like I showed on the previous slide, the inter-AZ data transfer costs at $130 per month. All of that adds up to $540 per month. And if you look at that math, it's saving 70% and having a fully managed service that will save you time and management overhead becomes a pretty compelling argument for looking at offloading those undifferentiated workloads onto a fully managed service. We also designed EFS to serve the vast majority of file-based workloads covering a wide spectrum of performance needs. This spectrum runs from highly parallelized scale-out jobs, those workloads that require the highest possible throughput, things like big data applications and media workflows, to single-threaded, latency-sensitive workloads and pretty much everything in between. I'm not going to go through all of the different uh, customers on this slide, but you can see we have quite a few customers and names you probably recognize that are leveraging and using EFS for various uses. And things like Thomson Reuters, they use it for storing the files of the different stories that come through before they get posted online. And so a lot of these different workloads are transitional. Some of them are used for genomics and processing of large files in big data environments. We basically are able to see, if we look at the broad spectrum of workloads, pretty much every industry and every type of workload is finding ways to uniquely use Amazon EFS in a very meaningful way. All right, so now let's dive in just a little bit more and talk about how to decide how to choose which website platform to use. So back in the earlier days of web development, most sites were built using code like HTML and CSS. This was a challenge for those of us who weren't professional website developers who did this 12 hours a day. It took time and was tricky to stand up websites. To some extent, this stigma still exists today, with people thinking that you need coding skills and a deep knowledge of HTML and all the other languages to build a site. Fortunately, this is no longer the case. With content management systems, or CMS, like WordPress and Drupal, and e-commerce tools like Magento. In a recent case study, or a recent study by W3 Techs, of all the website that they monitor that uses CMS, 55% of all those sites use WordPress. That's millions of websites that are built using WordPress and other CMS tools. These tools have an incredibly strong ecosystem with hundreds of thousands of developers and companies contributing to the platform, building tens of thousands of themes and plugins that we can use to enhance the sites. So what do you think about when you're selecting a website platform? What are you looking to build? A simple website, perhaps a blog, uh, perhaps a blog. Do you want to take advantage of free and open source tools to keep your costs down? Perhaps you can set up an e-commerce site, and chances are CMS or e-commerce system will be based on PHP and MySQL. While today we'll primarily be referencing some of the tools we and our partners have built for Drupal, WordPress, and Magento, the basic concepts we'll be discussing today are relevant to all major content management systems out there today. The final phase to get started with EFS is to run it. So with that, I'm going to hand it over to our friend Daryl Osborne to talk about all of the cool tricks and things you need to know when you want to run your WordPress.
Phase 3 of our webinar is going to be talking about how to build and deploy this website. So with AWS, we offer cloud web hosting solutions that provide you either if you're running a small business or a large business, maybe nonprofits, maybe even a government organization, with low-cost ways to deliver your website or web application. So whether you're looking for a marketing site or a rich media site or even an e-commerce site that Joe mentioned, we offer a wide range of website hosting options, and we'll help you select the one that is right for you. So with AWS, you can use really whatever CMS you like. You saw all of those that Joe mentioned earlier. These could be WordPress, Drupal, Magento, or any other one. So the concepts that we'll be discussing today, while we'll reference these three, they really apply to just about all other CMS tools available. And we make these tools because they're flexible, and they're really there to help build out these cloud scale websites. We have projects within AWS, which are step-by-step guides to walk you through this process. We also have reference architectures, and these include CloudFormation templates that will build out all of the AWS resources you need. Or you could even leverage our quick starts, which deploy fully functional, production-ready environments that you can start using right away. So, in this webinar, in the next few slides, I'm going to be referencing the reference architecture I wrote for WordPress. Even though you could apply all of these concepts to any other CMS or e-commerce site like Magento that you're going to be running. So first, let's go ahead and start out with a shared file system. So by moving the entire, in this example, WordPress or your website's installation directory onto an EFS file system, and then mounting it onto each of your EC2 instances when they boot, your website with all of its data will automatically be stored in this distributed file system. And this is completely, independent. So it's not dependent on a single EC2 instance. And this makes your web tier completely stateless. One of the benefits of this architecture is that you don't need to install, in the case of WordPress, plugins and themes on every EC2 instance. And this can significantly, speed up the installation and recovery of your site. So EFS file systems are distributed, as Joe mentioned, across an unconstrained number of storage servers, and really enabling these file systems to grow elastically and allowing massively parallel access to these instances. The distributed design of EFS avoids the bottlenecks and constraints that traditional file servers have. To leverage the benefits of this distributed design, though, we do recommend that you access EFS using multiple threads or using multiple instances. So this is where we recommend, scaling out your fleet instead of larger instances, scaling them out so you have a larger amount of smaller instances. So to ensure optimal performance when, for your website, when you're running EFS behind the scenes for your shared file system, we recommend that you have certain configuration settings and follow some of our best practices. So the first best practice that we have is really around the Linux kernel. So we do recommend mounting an EFS file system on an instance that's running Linux kernel 4 and above. During some of my tests, comparing it to Linux kernel, say 3.16 versus a 4.19, I've seen upwards to 2.8 or 3 times better performance when using a kernel version that's 4 and above. This really relates to some of the parallel features, I guess, of some of these more modern kernels. And there are a number of bugs related to older kernels and just NFS client protocols, not specific to EFS, but just NFS is in general, that you can avoid if you're running 4 and above. So this is one of the reasons why we recommend using Linux kernel 4 and above. The next best practice that we recommend is mounting the file system using our EFS mount helper. Now, a few months ago, we released this, and it is it's an open source tool. You can download from GitHub. It's also available on, within our Amazon repository. So on Amazon Linux, it's a simple yum install Amazon EFS utils, and your EFS mount helper is installed. This is a tool that simplifies the process of mounting a file system. It uses all of our best practice or recommended mount options including NFS 4.1. So we do support NFS 4, which includes NFS 4.0 and 4.1, but we do recommend mounting using 4.1. Again, some of the tests that I've done, I've seen a 2.8 or a 3x better performance when mounting using NFS client 4.1 versus 4.0. And this really comes down to some of the parallel features of 4.1. As an example, open and close operations, when executed by the same user ID or group ID, if the application executes those in parallel, the protocol, the 4.0 protocol, will actually queue those up and execute those serially. So that's one of the reasons why we see better performance with using NFS 4.1 than we do with 4.0. So again, best practice, use our EFS mount helper and mount using NFS protocol 4.1. The next option is larger I/O size. So if you can aggregate your I/O when accessing EFS file system, that is better. The larger the I/O, the more data you can get read from or write to an EFS file system, because the file system, the latency per file system operation is amortized over a larger amount of data, so that it actually improves the throughput that you're able to see. So if that's a setting that you can change within your application, then we do recommend using larger I/O size. The next best practice is related to multiple threads. So again, because this is a distributed file system, the more threads means better throughput, better performance. So we do recommend, if you can have multiple, versions of your site or your engine, web engine running on these EC2 instances, great. You get better parallel throughput to EFS. Also scaling out. So if you have more EC2 instances, then again, you're still able to get this and benefit from the distributed parallel design of EFS. Also, when you're writing to multiple directories to EFS, we can avoid inode contention, which is common with Linux file systems. When you're trying to update an inode with tens or hundreds or even thousands of instances, you could run into inode contention. So if you can write that to multiple directories, then you can avoid inode contention. Also, multiple instances. Again, this sort of goes along with multiple threads. So if you can scale your web fleet out to use multiple instances, then again, you're going to be able to leverage this distributed design of EFS. And then the last best practice that we have on this slide is really around monitoring. So we have 8 CloudWatch metrics for an EFS file system that allows you to monitor, throughput and IOPS for your file system, so that you can see how it's performing. So we do recommend, setting up perhaps a dashboard in CloudWatch and monitoring, total IO bytes transferred, so you can understand the throughput and IOPS of your file system, as well as, if you are running general purpose mode file system, the percent IO limit is a good CloudWatch metric to use and to monitor, as well as your burst credit balance. So there is a burst model within EFS, which may be useful to monitor, depending on your site and how heavy it's being accessed. Because as you add more data to your file system, you're able to achieve higher levels of throughput. So we have this burst throughput model that allows you to burst to higher levels of throughput when you have burst credits available. So that's another CloudWatch metric that we recommend our customers monitor and make sure they understand how it's performing. So the next item I'd like to talk about is sort of the database tier. So chances are, if you're listening in or watching this webinar, you're not a dedicated DBA. In the past, you could have taken on some DBA responsibilities. as a part of being maybe in a DevOps organization. But why worry about the database tier when you have other things to focus in on? So we do recommend leveraging Amazon RDS, or Amazon Relational Database Service, to run your database tier, because this really allows you to offload some of that heavy lifting related to managing a database service, so that you don't have to worry about it. When you use Amazon RDS, you can achieve high availability and high durability, because your database can span multiple availability zones. And it also allows you to set up replicas so that you can scale out your site as your site continues to grow, and you don't have to worry about that. So again, we do recommend leveraging Amazon RDS for your database tier. Database caching can also significantly reduce latency and increase your throughput for some heavy read application workloads. WordPress is definitely one of them. Application performance can be improved by storing some of the frequently accessed pieces of data in a memory sort of low latency database caching layer. So when a large percentage of your queries are served from this cache, then the number of queries that actually have to go back and hit the database is reduced. So this can actually lower your costs associated with running the database tier as well. So to take advantage of this, we do recommend, if a caching layer would benefit your site, to leverage Amazon Elasticache, and then you can sort of avoid that operational burden of managing and maintaining this cache environment sitting in front of your database. Elasticache makes it really easy to deploy and operate and scale this distributed in-memory cache within AWS. So there are 5 really key components on this slide, and really related to the web tier that I want to address. The first being EC2 instances. Now, selecting the right EC2 instance is important. Also, I want to mention Amazon Machine Images, AMIs, and how they can play a role in your deployment. Load balancers, definitely very important. Auto scaling, which is a service to elastically scale out and in your web fleet, as well as health checks. So AWS, we provide a wide variety of different EC2 instances, so that you can choose the best server configuration for your needs. You can have a good balance between performance and cost. So generally speaking, though, the compute optimized instances, so the C4s and the C5s, are really a good choice for web servers. They're a good choice for WordPress and many of their other sort of CMS sites out there. You can deploy these instances across multiple availability zones, so that really increases the reliability of your site, and the overall architecture is definitely improved because you're able to scale this out across multiple availability zones. Because you have complete control of these EC2 instances, when you log in to these instances, you have root access. So it really allows you to install and configure the software components that you need. In this case, with WordPress, you can install different plugins and different themes. But when you're done, you could actually save all this configuration information in as an AMI, and actually create an AMI, or Amazon Machine Image. So what this allows you to, when you need to scale your fleet out, you can scale out using this AMI. So you no longer have to install different components for your application on each individual EC2 instance, because they're already going to be baked in using this AMI, which is really a golden copy of your website. And you just spin these up as a part of the automatic auto-scaling process. So do consider using an AMI that has some of these components already built in to reduce your scale out times. So when when you distribute some of the requests, across your web servers, you really need to have a load balancing solution in place. So with AWS, we provide this capability through ELB, or Elastic Load Balancing, which is really a highly available service that allows you to distribute load across or to multiple EC2 instances. And because your website will be serving content via HTTP and HTTPS, we recommend that you make this ELB an ALB, or an application load balancer. And this is really an application layer load balancer, which will deliver and route the content of that application via HTTP or HTTPS to the various web servers, EC2 instances within your fleet. So as a part of configuring your ALB, we want you to configure health checks so that the application load balancer will automatically stop sending traffic to individual instances when they failed. If this is maybe a system problem or a hardware problem, we want to make sure that traffic isn't routed to these instances. As an example, for WordPress, we would recommend that the admin login page, which is the wp-login.php, be used as the health check, because this page will confirm two things. One, it'll confirm that your web server is running, and two, it'll confirm that the web server is configured to serve PHP files correctly. So there are the ability and options for you to create custom health check pages that can test other dependent services like on the database or other things, which you can totally do that. But at the least, we would recommend, if you are running WordPress, to do a health check and set up a health check for the wp-login.php admin page. One of the benefits and characteristics of AWS is elasticity. So as you launch more and more compute servers when you need it, it's really based on how your site is being driven by your customers, your end users. Auto scaling is that service that allows you to automate the provisioning and scale these EC2 instances up or down according to the conditions that you're in. So as more people are hitting your site, if you need to scale out your fleet, you don't have to manually intervene. It will automatically, based on some of the triggers that you set up, scale out the number of instances to accommodate all of the traffic that you're starting to see. Then when that spike has subsided, then it will automatically shrink your fleet, thus reducing the cost associated with running your site. So a very important part of running a website on the AWS cloud. So one of the last pieces I want to talk about is really this idea of caching content close to the end users. So websites today typically deliver a mixture of static and dynamic content. Static content would include files like maybe JavaScripts or style sheets. Dynamic content can include really anything that is generated from the server side. So this could be PHP code or data that is retrieved from the database, and this could be personalized for each viewer. So it's important to have a really good end-to-end experience for your customers. So a mixture of static and dynamic caching is important. So we do recommend putting a caching layer like CloudFront in front of your site. Now, CloudFront can cache both static and dynamic content. With dynamic content, while that content isn't necessarily cached, what it can do is it takes advantage of connection pooling, where it's still able to deliver this dynamic content to your end user much faster than if you weren't using dynamic caching. So again, we do recommend using CloudFront to cache static and dynamic content. This content could be stored on the static side. It could be stored in an S3 bucket, but you can, in order to configure and store some of this information in an S3 bucket, you may need to install plugins in your CMS application in order to do that. So some customers like to avoid more plugins, and they want to sort of minimize what they're doing. So in that case, you could still store your static content on EFS and set up your distribution using as a web server origin. And that web server is going to be coming from your EC2 instance fleet, which is being served, the data, the static content is being served from EFS file system. So that's definitely one option, or you could use static content from S3. The dynamic content is going to be served either from the database, which could be cached in Elasticache, or it could be served right from the EC2 instances coming from the EFS file system. So now that we've sort of built out and we've talked about the structure of your website, what we want to do is talk about how do we put that all together and start running and monitoring your site. So as you can see, this is what a typical site would look like. Now, if you go to our reference architecture for WordPress, it's going to look just like this. You have your shared file system that's going to be mounted to all your EC2 instances. You'll have an RDS cluster that basically spans multiple availability zones to serve up the database content. You could have an optional caching layer with Memcached or Elasticache sitting in front of that. And then you have this auto-scaling web fleet that will automatically scale up and down depending on the needs of your site. And all this is going to be accessed via an application load balancer that will distribute your load to these EC2 instances automatically for you. And again, because it's integrated with auto scaling, as more and more instances are added to your fleet, they will automatically receive traffic when they're ready based on those health checks that I mentioned. And then again, optionally, you could set up additional items and resources like storing static content on an S3 bucket, as well as caching some of this stuff using CloudFront. So there are a few recommendations that we have in terms of monitoring your site. So we do recommend monitoring your site using CloudWatch metrics. There's a lot of metrics you can set up and alert on in terms of your EC2 instances, your ELB, your RDS instance, as well as your EFS file system. So it's good to set up a mixture so you understand how all of your different components and tiers are working. So you have a good feel for how your application is running. And you can send alerts to alert you if any of these components start to falter. Also with the CloudTrail. So CloudTrail is a way to log API access to these resources so you can understand what is going on. Are you scaling out? Are you scaling in? What is going on in terms of your the components that AWS is automatically launching on your behalf when you set up services like auto scaling. We do recommend backing up your application, your shared file system, because we do, and it is an NFS file system. So we recommend using normal backup applications that you could be familiar with to back up your file system. We do have an EFS to EFS backup solution that allows you to back up your file system to another EFS file system, just in the case that you accidentally go in and delete something, or something happens, user initiated to your file system that could impact your site. So, with this EFS to EFS backup solution, it is a solution that a few of our SAs have put together to automatically back up your file system, say every day. And it's a scheduled process and very simple and easy to deploy. So with that, what we'd like to do is I'd like to turn it back over to Joe to wrap up and give us and review some of those best practices that we've already reviewed.
Excellent. Excellent. Thank you so much, Daryl. Okay, well, first off, at a high level, remember, use CloudFront to cache that static and dynamic content. And secondly, make sure you use Elasticache to cache your database reads. And of course, use OP-cache on all your web servers to cache precompiled PHP scripts to boost the performance. Each time a PHP script is executed, it gets parsed and compiled. By using a PHP bytecode cache, the output of the PHP compilation is stored in RAM so that the same script doesn't have to be compiled again and again. This reduces the overhead related to executing PHP scripts, resulting in better performance and lower CPU requirements. So just pay attention to those options. Store all data in Amazon EFS for ease of use, or static content in Amazon S3 for storage cost efficiencies. So again, the difference between static and dynamic content. Share the same Amazon EFS file system among sites. Add more data to increase Amazon EFS throughput. Set up those CloudWatch alarms. It'll help you make sure everything's running optimally. And then set up your ALB to trigger auto-scaling policies. And finally, there's a few resources out there that exist that I just want to bring to everyone's attention so that you are aware of them. And you can go to the resources page on the Amazon EFS web pages, and that's at aws.amazon.com/EFS/resources. In there, you'll see the WordPress best practices white paper. It'll guide you through utilizing the different scalable options for WordPress, and EFS is highlighted in there, how to use it. We also have a Getting Started project that's really popular for building out a Drupal website, and it'll talk about EFS and how to take advantage of EFS with Drupal. We have some reference architectures that will also help you with not just Drupal, but also WordPress and Magento. If those are services that you're different platforms that you're interested in using. And finally, we also have quick starts for Drupal, WordPress, and Magento. Quick starts will go into a little more detail and dive deeper on how to really deploy those with best practices included. So lots of good material on those three topics in particular. And again, as I pointed out, here's the URL so you can see it, aws.amazon.com, EFS/resources. Lots more here outside of even the website content that we've talked about today. So before I jump in and talk about, take some questions from you folks and have Daryl respond back, I wanted to hand it back over to our webinar moderators to give you a few little housekeeping tips here.